Welcome back. We are in lesson 111, and today we're going to talk a little bit more about conjunctions. So we are used to seeing conjunctions that we would graph on a number line that look like this. Right? 4 is less than x, which is less than 14. And we know how to graph that. We identify the 4, and there's numbers in between, and we identify the 14. And we would circle both numbers and draw a line between the two. And that's how we would do a conjunction that is represented by this statement, right? Okay, so now we're going to look at some conjunctions that are just a little bit more complicated than this. For instance, we have a conjunction 4 is less than x plus 3, which is less than 10. So that's a little bit more than what we're used to. This x plus 3 kind of throws us for a loop. We're like, what? So what we want to do is solve for x. We don't want to know what x plus 3 is. We want to know what x is. So we are going to solve in much the same way that we would for some other single inequality. So we're going to pretend that these are 3 different sides right here. And we're going to do what makes sense to do, which is to subtract 3 from all the sides. So we'll subtract 3 from this side, and this side, and this side, right? This becomes a 1. We bring down our inequality. This becomes x because these cancel. And then we bring down our inequality, and this becomes a 7. Now we can graph this. We know what to do with it. We draw a number line. We identify our 1. And we identify our 7, and we switch. We circle this because neither one of them have an equal, and we draw a line in between. And that's how we would solve to get to this conjunction inequality statement so that we can graph it. All right, so let's try one. Let's try example 111.1. And this inequality conjunction says to graph -5 is less than or equal to x minus 4, which is less than 2, and the domain is integers. Okay, so we have this section in the middle. I'm going to draw my little lines again because that helps me see it, right? Now we have x minus 4. So we're going to add 4 to both, or I should say all 3 sides, and perform my math. -5 and 4 is -1. We bring down our inequality. This cancels, so this becomes x. We bring down our other inequality, and this becomes 6. So now we know what to graph. We draw our line. This is -1, 0, 1, 2, 3, 4, 5, and 6. Right? But our domain says only integers. So let's start with -1 is less than or equal to x. Is -1 an integer? Yes, it is. Is it equal to? Yes, it is. So you circle it and fill it in. All right, let's look at this side. X is less than 6. 6 is an integer, so we can't include it. And we can't include the line between 5 and 6 because it's for integers. But we can include 5 because 5 is less than 6. So we need to graph all of the integers between -1 and 5. And that is how we would graph this statement. Okay? All right. So these are the ones that you're going to be seeing. All you need to do is solve for x. And if it helps you to draw the lines to separate them so you can see what you're doing, then do that if that's what helps. It helps me, and I hope it helps you. So let's clear this page. And let's move on to something called disjunctions. So far, the conjunctions means this and this at the same time. Disjunction is our word here. Disjunction means that they are taken apart. They are not together. So when we have a disjunction on a graph, it is going to be using the word or. This or this. When we have a conjunction, it is this and this. But a disjunction uses the word or. And we don't know which one, so we have to graph both of them. Okay? So let's look at example 111.2. We are asked to graph the disjunction x is greater than or equal to 3 or x is less than or equal to -2. And that is the domain of integers. All right, so let's just go ahead and put our number line up. We don't have anything to solve, so we can just go ahead and start putting this in. Let's find 0, 1, 2, 3, 4. Let's do 5 for the heck of it. -1, -2, -3. Obviously, I'm not worried about spacing. -5. All right, so if, I'm gonna switch colors. If x is greater than or equal to +3, okay? So we find +3 and it is equal to, so we fill it in. And x is greater than that. So we go to the right where the greater lives. Or x is less than or equal to -2. So we identify -2 and it has the equal sign, so we fill that in. Actually, I've already done this wrong. We identified the x is greater than or equal to 3, so we filled in the 3. Because the domain is integers, we can only graph the integers that are greater than 3. And 3 is included because of the equal sign. All right, and so now x is less than or equal to -2, so we identify -2. All right, and there's an equal sign, so we can fill it in. But we can only graph integers, so we're going to go less than -2 and fill in our integers. And we're going to indicate that there's more by highlighting or marking over the arrows at the end. And that's the only thing that we can do. All right, that's how you would graph the or. You're going to have a gap between your two statements. And that's how you know it's a disjunction as opposed to a conjunction. All right, let's try another one. We're going to do 111.3. And we are asked to graph x is greater than 15 or x is less than or equal to 10 and the domain equals reals. So that's all the numbers, right? So we can draw on the number line itself and include those numbers. So let's go ahead and draw our number line. Get our little arrows in here. And we'll get our 0, 1, 2, 3, 4. Ooh, that's pretty bad. That's not good spacing at all, is it? No. All right, 3, 4, 5, 6, 7, 8. Actually, I'm going to move this all down. Let's say this is -2, -1, This is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, now we can do it. And I didn't have to start way down here. I could have started at 4. It probably would have been better. X is greater than 15. Okay? X is greater than 15. We circle 15 and we go to the greater side. Done. Or X is less than or equal to 10. We identify 10. We fill it in because of the equal sign here. And we go to the less than side. Done. And because it's reals, we draw the line that includes all the numbers in between each integer as well. All right, that's all we have for lesson 111. Easy peasy. You guys can do this. I am quite confident that you can graph a disjunction. In many ways, a disjunction is actually easier to graph than a conjunction, and that may be why you did conjunctions first, so that the easy stuff would come later. All right, I will see you in lesson 112.